Hey guys, welcome back to my YouTube channel. So for today's video, vid I will vlog this chapter 4, all activities. So for review for chapter 4, network access. To support our communication, the OSI model divides the function of a data network to layer. Each layer works with a layer above and below to transmit data. Two layers of the OSI model are so closely tied that according to the TCP/IP model, they are in essence one layer. Those two layers are the data link and the physical link. So in this activity, you will learn all about activity in in all activity in chapter 4. You will learn, and let's proceed. So in this activity entitled physical activity physical layer terminology. So for instruction, description of the physical layer are provided in the table. Drag each physical layer term to its description. So here's the physical layer description. We have media that uses pattern of the microwave represent bits, capacity of media to carry data, media that uses patterns of light to represent bits, a measure of the transfer of bits across the media, and lastly, media that uses electrical pulses to represent bits. So our choices are fiber optic, bandwidth, through throughput, copper, and wireless. So first question is media that uses pattern of microwave represent bits. So these patterns, what do you call this? Like microwave. So this is the keyword, the microwave. The microwave form a like a DNA picture, like flow flowing the. So it is wireless. The capacity of a medium to carry data. Uh, the medium carry the data is bandwidth. So media that uses patterns of light to represent bits is fiber optic. And a measure of the transfer of bit across the media is the transfer of bits across the media is throughput. And lastly, the media that uses electrical pulses to represent bits is copper. So let's check if it is correct. Yes, all our answer is correct. So we have successfully matched each layer term to its description. So let's proceed to the next activity. So so our activity entitled copper media characteristic. For instruction, UTP, STP, and coaxial copper media characteristics are provided in the table. Click the appropriate field to match the characteristic to the media type. So we have UTP, STP, and coaxial. We have to the click the appropriate answer. So number one, attaches antennas to wireless device can be bundled with a fiber optic cabling for two-way data transmission. So attached antennas wireless to device can be bundled with fiber optic. So in the last activity, fiber optic is the light pulses. So we have Koshal counters EMI and RFI by using shielding techniques and special connectors. So we have STP, most common most common network media. Self-explanatory, it is UTP. Terminates with BNX, N-type of type, N-type, and F-type connectors. We have Koshal. So let's check if this is correct. So you have successfully matched each copper media characteristic to its media type. So let's proceed. So activity T568A cable pinouts. So for instruction, correct align the wire color to build a TIA EIA 568A cable pinout. Draw each wire color to its correct placement on RJ45 image in the graphic. So this is the bottom view, um, bottom view of the NRJ connector. So we have to drag this all this color to this. So we have to answer this, um, arrange. We have to arrange the color. So first we have green, stripe green, plain green, and red, and blue. And lastly, it's so we all arrange the all colors in cable pinouts in RJ45 connector. So we have to check if it is have a wrong. So it is correct. You have successfully chosen the correct T56A 68A cable pinouts. So I hope you understand this, arrangement of this RJ45 connector, because it is, complicated, because it is because it because you have to, arrange it correctly, or it is if you're not if you are not, arrange it correctly, your RJ45 connector will not, um, what do you call this, uh, will not arrange. So we have activity fiber optics terminologies. We have multi-mode, single mode. So description of fiber optic media are provided in table. Click the appropriate field to match the description to the fiber cable type. So can help data travel approximately 1.24 miles or 2 kilometer in 2,000 meters. I think it's multi-mode. Uses light emitting diodes LED as a data light source transmitter. We have multi-mode. Uses laser in a single stream as data light source transmitter. So single mode, because in this question, we have a single stream as a data light. So we have to answer the single mode. So used to connect long distance telephony and cable TV application. So in our house, um, we have a cable TV application. So we have a one TV. So we have to single mode because it is not a multi-mode for the one TV cable applications. So can travel approximately 62.5 miles or 100 kilometers or 10,000 meters. So single mode. So used within a campus network. So a campus network is a broad network, so anyone can connect it connect to the end devices. So we have to answer the multi-mode. So let's check if it is correct. It is correct. You have successfully matched each fiber optics description to its cable type. So let's proceed to the next. This is the last. So part 1, generic frame fields. Instruction: drag the generic frame field to its correct location on the diagram. So we have 3, 4, 5, 6, 7, 8, 9, 10. We have 10 slots and 10 choices. So we have first we have a header, a trailer. No. It is packet. We have trailer. We have frame start. We have addressing. We have type, control, data, and error. And lastly is the frame stop. So this is the um, correct generic frame field to its correct location. So this is the arrangement: header, packet data, trailer, frame start, addressing, type, control, data, error detection, then frame start. For header, we have frame start, addressing, type, and control. For packet data, we have data only. And for trailer, we have two. And this two is error detection, frame stop. So let's check if this is correct. It said you have successfully placed the order of the generic field names in the frame. So let's proceed to figure 2. So part 2 of the generic frame field is generic field. So description: and drop the generic frame field to its description. We have five um, five slots and five um, choices. Contains the IP header, transport the layer, PDU, and data. I think it's data. And identify the three-layer protocol to the LLC. In this identify the three-layer, we have type. And marks the end of the frame. So this is the keyword frame. And this frame stop indicator flag. Identify source and destination host by MAC address. Destination. This is the keyword. So addressing. So specify special flow control service. And lastly, we have keyword with the flow control. And we have flow control. We have control. So let's check if it is correct. And correct, we have successfully matched each generic frame field to its description. So this is the end of our this is the end of my video, and I hope you enjoy it. I hope you like my video, and thank you for watching. I hope you enjoy, and subscribe to my YouTube channel and comment down if you have a question, and goodbye.